Good day, everybody. Welcome to my course on pipeline buoyancy calculation. So today we will learn the calculation methods or procedures for pipeline buoyancy. Here in this image you can see that one pipeline is added with some saddle bags and one anchor. So the main aim of adding these saddle bags as well as this anchor is to restrict the pipeline from floating so that the pipeline does not move in upward direction when the pipeline is installed in water table locations or swampy areas. Basically, in by this we are mitigating the buoyancy forces and developing more weights on the pipeline so that pipeline buoyancy calculation is satisfied or we get satisfactory results. Let's move on to the actual course now. So before we start on this course, let's check what are the topics or points that we will be covering in this course. First is introduction, where we will be learning what is the meaning of buoyancy and what is Archimedes principle on buoyancy. That is very important and required for all types of buoyancy calculations. Then we will move on to pipeline buoyancy. So we will understand what is buoyancy in pipelines. Then what are the issues with buoyancy? Next, why is pipeline buoyancy calculation required? Then equations and steps for pipeline buoyancy calculation. Then key parameters affecting pipeline buoyancy. And finally, mitigation steps, and we will perform one example calculation to understand how to perform this pipeline buoyancy calculation. Now, who is this course for? I mean, who should enroll in this course, or who are the professionals that will be benefited by undertaking or enrolling in this course? As this is related to pipeline buoyancy, obviously the pipeline design engineers will be benefited. So engineers who are responsible for pipeline layout and design, they will be benefited by undertaking this course. Next, civil and geotechnical engineers, the engineers who are analyzing soil and groundwater conditions. Next, mechanical and process engineers, who are the engineers involved in mechanical design and fluid systems of pipelines. Then pipeline construction and field engineers, site engineers supervising installation, pipeline integrity and maintenance engineers, engineers handling operation, safety and inspection of pipelines. Then engineering consultant and EPC contractors, means professionals providing design and project execution services. And finally, students and early career professionals, individuals preparing for careers in pipeline engineering who wants to understand the basics of pipeline buoyancy calculation as well as the steps for performing pipeline buoyancy calculation. So those professionals should undertake or enroll in this course. Now, what is buoyancy? We already studied in our engineering courses the concept of buoyancy. So we all know what is buoyancy. Still, let's take a simple glance on that same philosophy, that buoyancy is the upward force exerted by a fluid. The fluid could be liquid or gas that opposes the weight of an object immersed in it. So in this image you can see that whenever an object is immersed in this fluid, here you can see one liquid is showing. So whenever the object is going to immerse in the liquid, an opposing force acts on that object, and that force is known as buoyant force, and that impact or tendency is known as buoyancy. So obviously, due to the weight of the object, it will try to immerse into the liquid or fluid, and at the same time a upward force will be acting, and it will try to resist that immersion, and that force is known as buoyancy. So buoyancy is the upward force exerted by a fluid that opposes the weight of an object immersed in it. In simple terms, it is the reason why objects float or appear lighter when placed in water or air. Some typical examples you might have already seen, that a ship floats on water because the buoyant force equals its weight. So whenever this buoyant force is equal or more than this object, then automatically the object will be floating. So here you can find a good example that a ship floats on water because the buoyant force equals its weight. Again, a helium balloon rises in air because helium is lighter than the surrounding air, and the buoyancy force is more than the weight of the balloon, and it pushes the balloon upward direction. Similarly, a stone sinks because its weight is greater than the buoyant force acting on it. So if you throw an object or a stone in a liquid pond or any water, so you have seen that it sinks. The main reason is that the weight is more than the buoyant force, so automatically it will move downward direction and slowly it will sink. So by now you know what is buoyancy and some examples where you have practically seen how buoyancy affects the objects. Now Archimedes principle, this is one of the very important principle that is relevant to buoyancy. Archimedes principle states that when a body is fully or partially immersed in a fluid, it experiences an upward buoyant force equal to the weight of the fluid displaced by the body. So when we are immersing this body, then the buoyant force that acts on the body, that is equal to the weight of the fluid displaced by the body. So this object, whatever fluid it will be displacing, the buoyant force will be equal to the weight of that. So to explain it, we can mention that when an object is placed in a fluid, it pushes aside some of that fluid. The fluid then pushes back with an upward force. This is the buoyant force. The size of this force depends only on how much fluid is displaced, not on the object's material. So if buoyant force is equal to weight, the object floats. If buoyant force less than weight, the object sinks. So whenever this buoyant force is less than the weight of the object, it will sink. And whenever it is equal to the weight of the object, it will float. And finally, if the buoyant force is greater than the weight, the object will rise. For example, that we have given in earlier slide example of helium balloon. So in that case, balloon is rising because the buoyant force is more than the weight of that balloon. Now till now we understand what is buoyancy. So what is pipeline buoyancy and why it is important? Now buoyancy in pipelines is the tendency of the pipeline to rise upward due to the displacement of soil or water equals to its volume. This is especially critical for buried pipelines in waterlogged areas, river crossings, or offshore environments. So buoyancy in pipelines refers to the upward force exerted by the surrounding fluid, usually water or wet soil. So we know that buried soils are installed underground. Now in some areas when it is below the water table, then there will be surrounding water or wet soil that will be in touch with the pipeline. So because of that, an buoyant force or buoyancy force will be acting on that pipeline. Now, so that buoyancy in pipelines is the upward force that is exerted by the surrounding fluid on a buried or submerged pipeline, which can cause the pipeline to lift, float, or lose stability if not properly restrained. So that buoyancy force, if becomes more than the weight of the pipe or along with the weight of the soil, so it may float and lose stability. It's an application of Archimedes principle to pipelines. So to maintain the integrity of the pipeline system, we should calculate or check if the pipeline will be lifting due to buoyant forces. Now, what are the issues with pipeline buoyancy? Now, one should be concerned about pipeline buoyancy in onshore pipelines because risk of pipeline uplift. If the upward buoyant force exceeds the pipeline's weight plus the soil cover, the pipeline can lift or float. Uplift may lead to displacement, misalignment, or buckling, compromising the pipeline's integrity. Next, potential for stress and damage. Uneven uplift can cause bending stresses, especially at joints and bends. Excessive stress can lead to cracks, leaks, or even catastrophic failure over time. Next, high groundwater or flood-prone areas, onshore pipelines in wetlands, river crossings, floodplains, or areas with high water tables are especially vulnerable. Seasonal or sudden flooding can temporarily increase buoyant forces dramatically. Next is impact of pipeline operations. Uplift may affect slope, gradient, and flow efficiency of the pipeline. Misalignment can cause valve or equipment malfunctions, increasing maintenance costs. The next is economic and safety consequences. Repairs due to buoyancy related issues are costly and disruptive. Floating pipelines can damage surrounding infrastructure and pose environmental hazards if their contents leak. So to summarize, pipeline buoyancy in onshore pipelines can cause serious structural and operational issues if not properly addressed. Even though it is more common in offshore pipelines, buoyancy can still affect onshore pipelines under certain conditions. So by now I believe that you understand or understood what is the reason that pipeline buoyancy calculation must be checked during design phase of the pipeline projects, and what could be the issues that can arise if pipeline lifts from its position where it is installed. So that's all for this introductory module. Now we will be learning slowly all the calculation methodologies in upcoming modules. Thank you. Happy learning.